now pleased to welcome Joseph Wright from the University of East Anglia. East Anglia, that's a beautiful English countryside. I went there also, that's really nice. He spoke yesterday about CUnit-TX, that's a package, really useful package. And today I think he will speak about a part of his work on the Lua TeX engine. We'll play his video, and he's around and he will be able to answer questions after the video.
Hello, my name is Joseph Wright, a member of the LaTeX team. What I'd like to talk to you about here is some work we've done recently on bringing new functions to the case changing ability of the LaTeX kernel. What I'm going to be doing is focusing on what I've called Unicode-land. So those of you who came to my 2015 talk in Darmstadt saw me talk about writing a new case changer for Expo3, which would allow us to do Unicode case changing, and I called that reaching Unicode-land. Here I want to show how we've then moved that on, improved it a bit, and also enabled it to support the needs of the LaTeX kernel, and how we've then brought that code into wider production use. So we're going to start off by just reminding people what is Unicode. So Unicode is a way of having a single code point for all characters we might want to input to a computer. Quote here from the Unicode website from Donald Knuth, where he points out that it's one of the most important tools there is for bringing understanding between people of different cultures, because it means we have a single way of describing a vast variety of different characters from the point of view of the computer, so different inputs. And Unicode isn't just about those inputs, it's about collecting up knowledge about how different languages, different cultures handle different parts of that input and produce different outputs, so that we can have standards that work between different computers. And in the main, that brings us considerable benefits. But we want to focus specifically on case changing. So I'm going to use Unicode's description of case changing, and they've described 4 different types of case operation. Lowercasing and uppercasing are the ones that people will be familiar with. There are a few provisos when you look at what Unicode talk about here, because we're not talking as in quite the simple terms that TeX lowercase and uppercase primitives use. In particular, we're not always talking about one-to-one mappings, and there will be context and language rules that can apply, as I've said. Title casing is the term that Unicode used to mean where you take the first letter of some input and you make it uppercase, and the rest you make lowercase. Now, I've put in brackets on the slide almost always uppercase, because there's a few provisos to that. If we think about a situation where we have something which looks like 2 letters at the start of a word, but it's 1 code point, we might have a special character to be used when we're title casing. Similarly, in some languages, most notably Dutch, we might have a special rule which applies where it's not simply the first character. So if we look at a Dutch word starting with I and J, that is uppercase, title cased as a single, as though it were a single code point, so it's uppercase I, uppercase J. So we have to allow for that and cover it. And then we've got one operation which isn't casing, but it's removal of case. It's called case folding. That's where we're going to compare texts in some programmatic way, not for typesetting, not for humans, but for the computer. Now, although that's not exactly the same as lowercasing, programmers often use lowercasing. It's not right, there are things that gets wrong. And what I wanted to do is we wanted to provide that as part of the support in Expo3 and potentially more widely. So they're the 4 types of case changing or case operation that we need to provide. What did I do in Expo3? So in Expo3, the starting point was to provide a way of implementing all 4 of those Unicode types of mapping. So as I say, the primitives in TeX provide us lower and uppercase only, and they have some other limitations. When we work through this list, we will see them. They use LC code and UC code, and I wanted to use LC code and UC code for storing as much data as we could, so what I'm going to call here the core data. And that's because particularly when you look at the Unicode engines, you've got quite a lot of code points that have a case mapping. And so as far as possible, the idea was to use that information. It also means that the users have got a way of modifying things should they wish to, although actually probably not going to be modifying the case outputs very much. But they support only one-to-one mappings, and I wanted to support one-to-many. A classic example there is the uppercasing of a German SZ. So the SZ traditionally is uppercased as two S's. There is now a move to a capital SZ, and that's a variant, and we'll at least think a little bit about that. But the point is that there are places where you don't have a simple one-to-one mapping. We also see that where there's a pre-composed accented character in one case, but you have to use combining characters in the other case, and so we need to support one-to-many. So we can't just store data in LC code and UC code. The Expo3 code wants to support context-sensitive mappings. So I've said the example is the lowercase sigma. So if you take uppercase Greek and you have sigmas in it, when you lowercase, a sigma in a word goes to what I suppose non-Greek speakers would think of as a sigma, and a sigma at the end of the word uses a variant form, a terminal sigma. That always applies whenever you're writing Greek characters. So that's a context and not a language dependent. So we can always expect to do that. It's not the only example, but it's one of the most prominent. We also want language dependent mappings. So the most obvious one there is the Turkish dotless I. So in Turkish, dotted I and dotless I are independent of each other. And so when you uppercase a dotted I, you make a capital I with a dot, and when you lowercase a capital I without a dot, you lowercase to a dotless I. But that only applies if your text is Turkish, so there you have to know the language. So the Expo3 case changer has a mechanism to support that, and things like the variants I just mentioned about the German SZ, and you can, in the same area, you can have support for language variants. And at the Expo3 level, I wanted to implement expandably. Why did I want to do that? Well, it's as a programmer, you might want to have a setting where you're saying, expand this material and case change it while you're going. And it's much more natural to say, put the expand first and put the case changing within that. Also, when you start working this through, we actually have to examine each token one at a time to do this work. And so that's actually basically means that working by expansion is relatively convenient. So that code was written largely for TUG 2015. There's been some refinements since then. We'll come on to one or two refinements in a moment. But at the time, it only supported Lua TeX and XeTeX, and it was an experiment in many ways. Could I do that task? Since then, we've had a move to refine our thinking about how Expo3 works, in particular the idea it's built into the kernel and that there won't be a separate LaTeX 3 format. So it's about bringing these ideas into the LaTeX 2e world. And so that means picking up some other ideas from the LaTeX 2e world. And one of the things we want to pick up lessons from is the package textcase by David Carlisle. So what textcase does, or did, is provide some additional wrappers around the lowercase and uppercase primitives to support some common uses for real text by users. The first is auto-escaping math mode. So math mode text shouldn't be case changed. A variable lowercase a is distinct from a variable uppercase a. And so you want to auto-escape math mode. We want to be able to handle cite, label, ref. Their arguments are things that shouldn't be case changed. So you need to know about those. And then you want a way of just excluding arbitrary material from case changing, and the command that David introduced was no case change. Why would we want to do that? So I'm a chemist. So if I put a chemical symbol, for example, for an element in the piece of case change text, I want that not to be case changed because that could change. You know, the classic example is cobalt has symbol capital C, lowercase o. Capital C, uppercase O is carbon monoxide. It's very different. And so even in all uppercase text, I would leave that case unchanged. The other sort of common case nowadays is something like iPhone, where the I of iPhone is left as lowercase. So those sort of situations, you want a way of stopping the case changing. Now David's done all of that using the classical upper and lowercase macros, primitives. So why would we want to go further? Well, the first thing is that Expo3 code, as I say, we've extended it. So now, not just Unicode input in Unicode engines, but Unicode input in 8-bit engines will work. So that means that what happens now is it performs effectively a protected at edef on the input, but done in an expandable way. And then when used with an 8-bit engine, we look for the bytes that indicate a code point that needs to be case changed. Now, at present, the support there isn't every single possibility because there's only certain code points that people really work with PDF text. So Western European languages, Russian, Greek, but not, for example, languages that have been added to Unicode. More recently, there's quite a lot of languages that do have case, which people only use with XeTeX and Lua TeX, and I haven't added those code points at present, but that's simply a question of whether it's useful work to do. So the first thing is that the Expo3 code now can support a full range of case changing across the engines. The second one is that we've got a wider use of protected, and particularly for actives, I've said. So what that means is, in the latest kernel release, we've changed the definition of active characters used to support 8-bit input in PDF text so that they're engine protected. And that is useful because it means that they can be put in places where in the past they couldn't be put because there's a raw edef being applied. That's useful for passing code into Expo3. It's useful because we can use these now. We can treat Unicode input in 8-bit engines almost as though it was an engine native, except in writing out command names. But that actually breaks the traditional way that MakeUppercase and MakeLowercase handled accented characters. And so we needed to readdress that. It gives us the opportunity to get the full Unicode range without needing extra support. Now, what I mean there is, obviously, I'm not the first person to look at case changing Greek or Cyrillic, or any of these other languages or accented characters using the classical 8-bit setup and uppercase and lowercase. But each of those solutions has been independent. So Greek has its solution from Babel, Russian has a solution, etc. But they're not all integrated together. The new case changer, everything's integrated into one mechanism. So it means that if you've got a document with multiple languages, you don't need to worry about, well, this needs to be loaded and that needs to be loaded, and they apply in different places, because the Expo3 case changer we're going to be using behind the scenes handles all of this using a one mechanism. Language dependent supports are possible. It's not added yet, but I think it's very likely we have an idea about how we're going to add that for the next LaTeX release. The reason it hasn't been added yet is there's still a few little bits to sort out with Babel and Polyglossia about how we describe languages, but the idea is at the Expo3 end, that's certainly doable, so we're likely to add an optional argument to support language codes, and so it'll be much easier for you to specify this string should be uppercased in Cyrillic, or Greek. Turkish is an obvious one. So what have we done? Well, the first thing is there's some things we haven't changed. MakeUppercase and MakeLowercase are still there, and unlike the Expo3 versions, these are not being done by, they're not expandable, they're still robust commands. In fact, we've changed the definition so that they're engine robust, or essentially engine robust. There's a little bit of technical change, so we haven't made those outer document commands engine robust, but inside the implementation there's an engine robust command. So if you put these in an edef now, they won't explode. We've taken no case change and we have moved that from textcase into the kernel. So that becomes a kernel command and it will apply in the same way as the textcase package used to. So what we have done is we've brought those functionalities of the textcase package into MakeUppercase and MakeLowercase. And then what have we added? Well, the first thing is I talked about title casing, and traditionally LaTeX hasn't supported that. What people have done is they've split their input, used MakeUppercase on the first character and used MakeLowercase on the rest. That doesn't really work for 8-bit input with PDF text anyway. It also can't account for things like non-letter characters at the start of a string, and it can't, as I say, deal with those special situations where there is a non-standard character. MakeTitleCase can. So we've added that in, has exactly the same semantics as MakeUppercase and MakeLowercase, but it will do that work for you. Another sort of user-focused command is case switch. So case switch is for the situation where you've got something which you simply can't do by expansion. So in our non-expandable typesetting situation, you want to vary the output depending on what case is being requested. And so that takes 4 arguments. The output to give if you're not in a case changing situation, the output to give if you're uppercasing, the output to give if you're lowercasing, and the output to give if you're in a title casing situation. So what you can do is you give that command, you put those 4 situations after it, and you will get then the case changer will then select the right pathway, and that will be output as is. There's also 2 commands aimed more at package authors, class authors possibly. So we've got add to no case change list. You might guess that that is going to add commands on, so that rather than having to wrap them up in no case change, they're automatically handled in that way. So that's how we would add, say, another citation command. You'd add that, and that would say don't case change this command and its argument. And we've got declare case change equivalent. So that's for the situation where in the rest of the document you've got some definition that won't work or isn't appropriate in a case changing situation, but you want to swap it out. And that's what declare case change equivalent does. You can swap something out. So that's also a way that if you have a situation in a document where you know that some command just isn't working because it's been case changed badly, and you say, well, I know that in that situation I can swap it myself for something else. This can substitute a command by some tokens, and then it will be replace that. So that's a specialist situation, but it's useful. Those 3 there, case switch, add to no case change list, and declare case change equivalent, can build up to provide some sophisticated modification of what's happening. So what I'd like to show you there is really that Explore3 is delivering in the 2E context. What we've done is we've taken some code we've developed as Explore3 code, we've brought it into LaTeX 2E. We're using Explore3 to deliver those. It doesn't matter to users. You don't have to worry as a user that the fact that the mechanism has changed, but under the hood, that's what's happening. Benefits of Explore3 are arriving to users today. There'll be more benefits. You're going to see this in many places. We're bringing in new ideas with benefits to users which are hard to deliver any other way, and which builds towards that idea of supporting modern inputs. Part of the tagged PDF project is not just doing the PDF tagging, but things like we need to be able to support Unicode in and out, and that's where things like the case changer come in. So I'd like to thank you all for your attention. I'd like to thank the rest of the LaTeX team. I'd like to thank the Unicode Consortium for the data, the databases that support the case changer. And I'd like to support all those users, both of LaTeX and other systems, who've provided the test cases that I use to build up the back end to this code. Thank you.
Thank you very much, Joseph, for all the explanations. Are there some questions? Or maybe you want to add something to your video?
I mean, I saw, Ulrika in the previous talk mentioned MakeUppercase working in bookmarks, and of course that does rely, that does take place by expansion, so that's more or less directly using the Explore3 code. So another advantage I didn't mention is that other than the expandability, which is now really just a wrapper because of the way that MakeUppercase has traditionally been used, you now get you'll get exactly the same behaviors in bookmarks or other sort of expansion contexts where you're swapping out the definition to MakeUppercase and MakeLowercase as you would for the more classical situation. And I think, as I said, I actually watching the talk, I realized I didn't go back to the business about variants for the capital S set, but the idea is that potential to add a language argument should allow us also to let people sort of select that kind of variant behavior. There's a few other specialist situations where you want whether a variant of case changing, and having that just sort of built in is something that I think is important.
Right. There is a question from Boris.
I think I have a very, it might be a very stupid question or naive question about title case. There are basically two conventions with title case. The reasonable European convention when only the first word has the first letter uppercase, and the strange American convention when you uppercase all, but not all letters in title. You don't uppercase articles, you don't uppercase some. So basically, when you say title case, do you understand that Unicode standard requires you to support both? Or
no, so okay, so the second situation you've just described. So that's why that I originally called it mixed case, because title case is used for with slightly different meanings depending on who you ask. So, but we sort of resolved that because that's what Unicode called it, and because we're trying to implement Unicode, that's what we're going to go for. So, Unicode title case is strictly it's the first letter. What exactly you do about if your string doesn't start with a letter is a bit complicated. We skip over non-letters. The first letter code point should be uppercase-ish, and the rest should be lowercase. What you described, where you it's not just the US, you also do it in UK English, where you uppercase everything that's not a small, normally a small word is how it's normally described. That's normally called sentence. Well, that's another kind of, you've got sentence casing, which is where you start each sentence, and you've got that kind of title casing. And that requires you to make there's a judgment call in what words count and what words don't. Now, Will Robertson did a while ago, I think only on the team list, suggest a way of doing that expandably, and it is doable, but that's sort of not Unicode title casing. They mention it in their document, but it's not, because that operates on a word basis. You have to make a judgment on the words, not on the code points, and it's not really context in the sort of Unicode case changing approach. That is not covered. That is, I don't have another good name for it. It's possible, but you're then even more dependent on the language you're dealing with, and even more dependent on special words, detecting things. It's quite tricky to do because, for example, there you have to capitalize, certainly in English, if you have a new sentence in a case changed from you would capitalize that even if it is one of those short words, but you have to pick up then whether it's a full stop or whether it's, you know, something else like an abbreviation. So that's a lot more tricky, and it's very difficult, you know, even defining what's supposed to happen is tricky. So no, it doesn't cover that. It is just the idea that you take, you know, you look for the first code letter-like code point, you make that uppercase-ish, you make the rest lowercase, and that's it. So single word, really.
Yeah, thank you. Unfortunately, some publishers require it, and it's a mess. Thank you.
Yeah. I mean, it's something to think about. It's certainly as I say, you can. There are ways of doing it. It's a sort of an extension, but it would probably need dictionaries and things, and even then you need exceptions. It's probably one, maybe next year.
Jonathan, it's your turn.
Oh, thank you. Thank you for your talk, Joseph. I'm going to ask a slightly old question. I don't know much about our Unicode, but I know a lot about Python and I know how to search for things. So let me get straight to the point. Do you give the same answers as the library provided by Apache for your title case? Okay. Let me tell you why I asked this question, which is that I found out that Croatian has a single letter, NJ, that exists in Unicode in 3 forms: capital NJ, capital N, small j, and small.
Yeah, that middle one's that's the title case. That's where I say it's sort of uppercase. That's one of the ones where you have this title case letter.
Yeah, so I'll report what Python does, because they fixed it in 2019, which is that they gave the wrong answer for capitalizing a word that begins with any of those NJ letters. And the bug report said, I think we should do what Apache does. And I'm just wondering if you've got the same answer for your title casing.
Well, I know what the reference. I mean, I looked at some Mozilla stuff for Greek because they had some good test cases there. That one's quite clear, really. Uppercasing should give you the code point for the uppercase. The cap looks like 2 uppercase letters. Lowercase should give you the 2 lowercase letters, and title casing should give you the one that looks like 1 uppercase letter and 1 lowercase letter, but that are 1 code point, and that's what you'll get.
So, sorry, that went by a bit quickly.
So I said there are three things you can do. If you make a string all uppercase and it's got one of these code points that looks like has a human would look at it and go, it's 2 letters.
I'm talking about capitalize.
So if you're capitalizing, that's uppercasing, then it should all be capitalized. If you're and all 3 of those code points will map to the same position. So all we do, Jonathan, is we read the Unicode data file. So this is the current Unicode data.tex, and that's what's used plus special casing.tex to define the case changing. I have because particularly in tech and even other languages, I suspect some of the special casing and the context dependency is a bit tricky. That's done by coding it in by hand and test casing individual cases. But the one you've just talked about, that Croatian, that would be done automatically by simply reading the fact that Unicode data.tex. I'd have to look at the code point, but I assume it'll have, rather than 2 entries, it'll have 3 entries. It'll have an uppercase, a lowercase, and a title case code point, and you use those 3. Anything that's got a title case code point is stored. They're all handled. They're pulled out. Anything that's your title casing and it's got a title case code point is used in preference to the uppercase code point for that case changing operation. So that's how that's implemented. But I haven't used any Unicode. Make it. If you read the documentation, they describe the algorithm in general, but they don't give any. It's not a hard and fast rule because, as they point out, it's not immediately straightforward exactly how you handle everything, and so they do allow you to derogate from the sort of completely automated position. And there's only a very small number of those title case-esque code points. They're mainly there they're essentially there for historical reasons. But well, I can't tell you. I haven't tested that particular one, but I have tested other ones, and they work. So it should. I assume. Of course, there are other situations where Unicode is. So Greek is the one where it's a bit more tricky because what Unicode encoded into Unicode data doesn't necessarily agree with what people who speak Greek think should happen, which is why you need the language field, because Greek's particularly awkward because Greek letters are only used to write Greek, whereas other letters are used to write multiple languages. So you don't get this idea that the letters and the language are quite, well, most of them. The other ones with case. So if you look at Cyrillic letters, they're not only used to write Russian. If you look at Latin letters, obviously they're not only used to write, well, whatever language you decide, Latin, I guess. But Greek letters are only used to write Greek. So there's this kind of language glyph sort of merging. Yeah, so I haven't checked any specific other rendering for everything. I say the one that I have checked is for Greek, and Mozilla have a bug report about handling of Greek accents, which is very, very tricky, and was the last major part to get right, because that was very, very, that's Greek cases, mind-bending.
I'll continue this conversation elsewhere, perhaps as a GitHub issue. What impressed me, 2 things impressed me. The one is this library gives the same values for capitalization as that library. Seems to be a very, very useful property, provided at least one of those libraries is right.
There isn't, Jonathan, there is no right. You say the Unicode documents are quite clear about this. There is no, they don't specify this is how it must be done. They say this is how you can do it, but you're allowed to derogate. So there is no one, there isn't a reference implementation that's right.
I said at least one of those solutions is right. They could both be right and different.
I see what you mean. As I say, I haven't checked it against any specific other implementation because there isn't an obvious one. I mean, it would be.
Well, there's a point behind
it, I guess.
There's a point behind all of this, which is Unicode will be a lot easier if the same algorithms are available in different platforms which gave the same results, and that these algorithms had the same names.
I see your point. It's tricky.
And Apache seems to be on this limited evidence, the leader for this. But that's all. And
I think
this is a technical point about Unicode, but the point I wanted to make was text handling systems should deal with Unicode in the same way wherever conveniently possible. That's all.
If I can just address that, the conveniently possible is the tricky part, because of course, if I'm implementing this in macros in tech, then so if you want to look at all of the Unicode data, we have in a classical tech engine only LC code and UC code to carry that around, other than just storing things in macros or in font dimensions. And so tracking things like, there's a lot of other properties that I technically should look at that I don't. So for example, I use the fact that things are cat coded as a letter to decide if they're letters or not, essentially, certainly for XeTeX and Lua TeX. Now, formally, I should be loading all of the properties. There's a Unicode property about whether something's a letter or not, and it tells you, for example, if you get to the end of a word, what's an interword character, what's the space. Now, tracking all of that it's doable, but it would be a heck of a lot of work to carry all those tokens. It would be much slower, and so there are some approximations. For example, what constitutes the end of a word is where you get to non-letter tokens, certainly in XeTeX and Lua TeX. Trickier in PDF tech, because of course you've got the 8-bit situation and actives. So you're never going to. I can see there will be situations which will be handled differently because of that, and I think the balance of performance, memory usage, and reasonable outcomes means that it's not likely that I try and load all of that data. If you're purely going into Lua TeX or Lua MetaTeX, you could do, because you could do everything in Lua and then you could create appropriate tables. But in XeTeX, PDF tech, PTeX and UpTeX, tricky. You would use you'd blow an awful lot of data, and I think it'd be very slow.
So LaTeX is not as suitable a language for Unicode processing as is the C language used by Apache.
I assume you mean the ICU libraries when you say Apache. Well,
that's all. It's just.
That's fair. I mean, yes. I mean, you wouldn't. I mean, text macro. We don't have flexible arrays other than building in hash tables. We don't have. There are certain data structures that you end up constructing from macros, and they're not as suitable. No, I mean, no one's going to pretend. I'm certainly not pretend they are.
And we're getting a consequence of this, and as long as we understand.
I think it's pretty well. No, I can imagine situations where, particularly if people play with cat codes to force strange results, you would get some strange results. But I think in practice, it's very unlikely that those situations would arise. But I'm certainly not ruling them out.
I'm happy to leave this at this point and perhaps continue elsewhere.
Okay.
Thank you very much for your detailed response and for your very interesting talk.
Thank you, Jonathan.
Werner, can you speak?
Hello, can you hear me?
Yes. If you have a camera, I can.
Yes, you can do that too. Okay. Join as panelist or stay as attendee?
Yes,
what shall I press?
The blue button.
The blue one. Okay.
And now we cannot hear you, but confirm again.
Can you hear me now?
Perfect. Yes.
Okay. I have a simple user question. There are languages like Gaelic that have uppercase letters in the middle of a word. I'm just wondering, how is this handled in LaTeX?
There's no, I mean, there's no special handling. I mean, that's sort of typography question in terms of, you know, is making something uppercase appropriate for that language? So, I mean, obviously, if you don't apply a case changing operation, you get what you put in. Not really sure what
about this language. So I have no idea about these languages that have a lowercase letter at the beginning and then an uppercase letter in the middle of the word. If I just think of words like McDonald's, you also have.
Well, that's where the sort of no case change command comes in. So you can, as I say, I mean, you can use that to say, you know, if you put that in the case change, that doesn't do anything outside the case changer. That's a no op. It just disappears. Inside the case changer, that's a marker internally that content shouldn't be case changed. As I said in my talk, you know, as a chemist, chemical symbols can't, to me, and it sometimes, you know, some editors would disagree with me. Some editors would say it doesn't matter, you're uppercasing it has to be uppercased, and I'd probably have a row with them because I'd be like, well, no, you've changed what you know, maths is the thing that people sort of seem to accept. You don't case change maths, and so we've made that automatic. You don't case change. I don't think you case change chemical symbols. You don't case change, as you say, special things like McDonald's is a fair one. iPhone was the one I pointed to, but you'd have the same. If you wanted to protect a word from case changing, then you could apply no case change. Haven't tried to automate that on a language basis that I know of. I haven't seen any sort of guides that would suggest that you need to automate that. It would be possible because the mechanisms are there to pull things out on a per language basis. We haven't made a sort of public interface for people to define their own language variant stuff because most of that code, there's only a few, well, we had a quick discussion about it internally. There's only, that we know of, a small number of languages where you need to do context dependent stuff, and the implementations are non-trivial. So we felt that we wouldn't make that public. If it turns out there's more situations that need it, then we could revisit that. So it's certainly possible we could make that more automated or more public, but at the moment, without, you know, it's the sort of classic programmer thing. Bring me examples and test cases, and I will go about implementing them. But without those, I'm not going to try and implement something based on, oh, this might be cool, because this code's already pretty complicated internally. I didn't talk about the tech. So last time I talked a bit more about the technical side. This time I've tried to focus more on what you're going to get as an outcome. But what we have to do is, because to preserve how things work with PDF check, etc., you have to essentially implement EDEF, well, protected at EDEF, but by expansion, and that's a bit long-winded. And then you have to do the case changing, that's a bit long-winded.
Asking about the implementation, I was just curious how such languages, excuse me, just wondering how such languages that have uppercase letter in the middle of the word are handled by case changing commands. It was just an innocent question of an user, you know.
What I mean is, at present, there's no special handling. It would work through, and you'd see, you know, it's an uppercase letter. If you're uppercasing, it stays the same. But one could, I'm just trying to say, one could imagine adding special handling if there's a you know, I like you, it's not a language I'm familiar with in terms of the typography, what the traditions are, and so without that information, it's tricky to know what might be appropriate. You would need someone who knows about the traditions of that language, and that's where anything involving languages, of course, that's why you want things like Unicode, where things in the CLDR get collected up from lots of people, lots of experts, about how different aspects, all sorts of different aspects of different languages are handled, because you can't be an expert in all of these things, and you do have to ask. You know, you see some of the email trails for those things, and they find people who do know about those languages. So I think we'd need to find someone who knows about those languages, is my answer.
Okay, thank you very much.
If you can accept one more question, Manfred in the Q&A is asking for some advice.
Yeah, so I saw that about how do you know about good practices. So so the team are currently updating. We've got for the next kernel.
Could you read the question first, so okay, everyone can see it?
Okay, sorry, yes, okay. To move a lot of documentation into the future, What do writers have to care about? Is there a collection of good practices to follow for migrations to the new world? Okay, so I think we are updating. So there's a long-standing file called user guide, USR user guide for LaTeX, and we've started one called user guide 3, which is trying to bring in some of these new ideas. What we're actually going to do is we've looked back, and user guide was written primarily when LaTeX 3 was launched. So the plan is to move that to rename it user guide old, and user guide, the name will be taken up by a document which covers some of these new ideas, trying to give guidance on that. I know that Frank is working hard on 3rd edition of the LaTeX companion, and I am sure that in there, I haven't seen all of it, I've seen some bits. I am sure that he will be giving lots of good advice about best practice. But yeah, we are writing new documentation. I've got some open tasks to do. I was doing some earlier today about working on exactly that, writing better documentation for it. So we know that there's some need for helping users with a lot of this stuff, and we are working on it.
Thank you very much again, Joseph, for your talk and all the explanations and answer to interesting questions. I think that